Hey guys, hopefully you're having a wonderful Tuesday and you enjoyed your 3-day weekend off. Let's get started on some algebra here so that you guys can get done with your homework and hopefully go enjoy the beautiful day outside. So we are talking about the second part of your guided practice 1 through 10 that you did a couple days ago, where we were talking about expanding, and that is one of your vocabulary words, which on page 239, expand and factor are your vocabulary words. And we already talked about expanding. It's using the distributive property to expand the algebraic expression. So if it has 2 and it's outside the parentheses for r plus 8, that just means r plus 8 2 times. So you do another r plus 8. And then when you go ahead and combine all of those terms, because you'll have 2 r's, 2 8's, r just becomes 2r, 2 times 8 we know is 16. So remember, like we learned in our entry task this morning, I need you to show your work and actually show that you're expanding that out to show it just like this: r times, or 2 times r plus 2 times 8, and then do the actual combination of 2r plus 16. So that would be called expanded form. So that is our first vocabulary word. To expand is to use distributive property to expand the algebraic expression. So the one we're going to work on today, is going 2 pages over, all the way to page 242. And your other vocabulary word that is for this unit is factored. And essentially, we talked about this morning, that's just the opposite of expanding. So the algebraic expression can be factored by taking out the common factor. So just like if I have, we talked about this morning, a factor tree, and I have 9 and 3 that I'm going to, or actually let's do 9 and 12 that I'm going to factor out. I'm going to take 9 and factor tree it with 3 times 3. Also, I could do 1 times 9. So the factors of 9 are 1, 3, and 9. 1, 3, and 9. Then if I were going to do that with 12 so that I could find a common factor, 12 factored out is 6 times 2, and then I could break that down even more. 6 can be 2 times 3, and I bring down my 2. Or it can also be, another way to factor it would be 6 times 1, because everything can be factored with a 1. So we're actually not going to include that as a common factor, because everything can be times by 1. It's just itself. So the factors for 12 would be 2, 3, and 1 and 6. 1, 2, 3, and 6. So now if I'm looking for a common factor, remember, I would look at what they have in common. So they each have 1, but remember we said we're not going to count that because everything has 1 as a common factor. So that can't be a common factor. The common factors are not 2, because 9 can't be times by 2, and they both have 3, they don't both have 6, and they don't both have 9. So the only common factor that those two numbers have in common is 3. So the reason I'm having you look at that is just to remind you what factoring something out is, and then how you find the common factor, and we're going to do that with an algebraic expression. So expanding was just writing it all out. We are going to find a common factor. Taking out the common factor is how we're going to factor an algebraic expression. So you can expand, they're giving you the example of 3, and then you are using distributive properties to multiply that by 4z and plus 1. And so essentially if we wrote that out in expanded form, it would be 3, and we're going to do 4z plus 1 3 times. So we would just write it like this, 4z plus 1, 3 times we're writing that. And then if we go ahead and say, okay, now we need to combine like terms and rewrite it. So I'd have 4z plus 4z from all of these places here plus 4z. And then because the 1 is not like the 4z, because it's not a like term, it doesn't have a z after it, I would say 1 plus 1 plus 1 to take from all these. Now I'm going to combine those like terms. 4z plus 4z is 8z, plus 4z again would be 12z, and 1 plus 1 is 3. So now I can just write 12z, and remember we've been talking about every number in the world is positive unless it has a subtraction or a negative sign to the left of it. So if it's positive, we know it will be plus 3. And especially because we had no subtractions up here or here, so we know it will be plus. So 12z plus 3, that's the expanded form. But what they're saying is you can also find it going the opposite way. So our answer was 12z plus 3. Factoring is just going to be the opposite, where this right here will be the problem that they give you, and they want you to figure out what this being the answer up here is. So they're saying here's 12, here's 3. What's a common factor? Just like we did over here, if we factor that out, what is the common one? And so we're going to do that with 12 and 3. So we're going to say, okay, because I don't know what z is, I can only work with numbers right here. And then when I write my answer, I need to make sure I include my z. So a common factor of 12 and 3, obviously 3 is just 3 and 1, right? 12 could be 4 and 3. Or it could also be 12 and 1. Or it can also be 6 and 2, but then that would factor down. This would be 2 and 3 is what equals 6, and we bring that down. So essentially R and up here, sorry, I didn't fully factor that one out, and then it would bring down our 3. So here's essentially, remember we don't use 1 because everything has 1. So then what are our factors all the way boiled down? This one's not boiled all the way down because 12 still has factors as we found right here. So this one we can disregard. Both of these just factor down to 2's and 3's. So we know the factors of 12 that we're going to use are 2, 3. We can also use 6. I broke the factorization all the way down to prime factorization, but these are still factors of 12. So, and 1 is, and 12 is, but we don't use 1 usually because everything has 1 in it. So these are the factors, and the factors of 3 we found 3 can't be broken down anymore, and the other one is 1 that we're not using, so really the only factor we can use is 3. So the only common factor for 12 and 3 is 3. So because we found a common factor, can't I just write this problem that they gave me here and say, well, if 3 is the number I have outside my parentheses, then I can go ahead and say with my original problem right up here, if I take the 3 out and put it over here, 3 times what is 12? So that can just be 4 now, because 3 times 4 would be 12. Z, and 3 times what is 3? 1, or 3 will go into 3 how many times? 3 will go into 12 how many times, whichever way you want to say it. So essentially, if I take the 3 out of the equation by putting it on the outside, saying I need to times it by all the things inside, and put 4z here plus 1, that would be the answer to me factoring this problem out. Because 3 times 4 would be 12 plus 3 times 1 would be 3. Make sure I add my z here. And that is how I can check to make sure I got the right factorization, is I can go ahead and say, okay, well, let me actually do the problem, and does it come out to the original problem that they gave me, 12z plus 3? Yes, it does. So if you didn't understand that, I'm going to try to walk you through one more over here to help explain it a little better. So we can expand this expression that I just took you through. And it says you can also start with that expression, which is this one right here that I scribbled out, and you can write it as the answer being with the 3 taken out, and then if you times it, it would actually equal this. So that's how we would factor this problem. So let's try it with this one here. The A on page 242. Walk through it with me. So we're going to factor 2y plus 10. First thing I need to ask is, what is a common factor between the numbers that I have, a 2 and a 10? We know that, well, 2 will go into 2 one time, right? 2 will go into 10 5 times, right? So I go ahead and put my y down here and my plus, and then I need to make sure I take my common factor, which was 2, goes into 2 one time, 2 goes into 10 5 times. That was my common factor, so I'm putting it on the outside. The way I can check that problem that I just factored out is I say, okay, well, 2 times 1 is what? 2 times 1 is 2y. Now 2 times 5 is what? 2 times 5 is 10. So I can go ahead and, does that equal my original problem they gave me to factor down? Absolutely. So I know I factored this out right. So let's go down, and first, if they want to do the long version that I did with you the first time, is they're factoring out 10. They're saying 1 and 10 or 2 and 5. Then they factored out 2y, would be 1 times 2y or 2 times y. And then they said, okay, well then here are all the factors, 10, 2 and 5, and 1. And over here, same thing, 2 was the factors, 1 and 2 and y and 2y. So if you are excluding 1, which is what we talked about, 1 is a factor of everything, so we're going to take that out as a common factor. The common factor of 10 and 2y is 2, which is what we got right here. When I just did it the quick way of, what do 2 and 10 have in common? Well, I know 2 goes into 2 one time, 2 goes into 10 5 times, and I rewrote it down here. So they just went ahead and rewrote it. So if my common factor is 2, 2y plus 10 was our original problem. So I would go 2 times y plus 2 times 5. That is my common factor is 2. So I put that outside. I take it out of the equation and put it on the outside with the parentheses for y and 5. Then I can go ahead and do that actual math, 2 times y, 2 times 5, and it will give me 2y. So we went ahead and checked. So factoring is just the inverse, or another word for that is opposite, of expanding. You can use expanding to check your work. So hopefully that makes sense to you. One thing I did want to go over is, since that is essentially right here, they said, okay, our original problem was 2y plus 10, and then when we went ahead and factored it out to 2y plus 5, those would be equivalent equations, because essentially 2y plus 10, once we factor it out, it's just a different way to write it, where 2 times on the outside of the parentheses, 2 times y is 2y, 2 times 5 is 10. So they're equivalent equations, and you worked a little bit on that on your math last night. So real quick, hopefully you guys are getting that. If not, look at page 243b, factoring 6z, and you can walk through that or go back to that. But otherwise, unless you call me or let me know, I will expect you will have all 11 through 26 done tomorrow for class. Have a great day.